All right, let's look at this problem. We have a 0.2 kilogram ball is attached to a light string. It swings in a horizontal circle at a constant speed. The length of the string is L, and it makes the angle 15 degrees. So this is 15 degrees, and then this is 3 meters. Draw a free body diagram, set up Newton's law. Okay, free body diagram, right? We're going to have gravity acting downwards towards the center of the Earth. We always have gravity, and that's mg. Then what's touching it? Ground. There's no ground touching it, no surface touching it, but there's a rope touching it right here. It's going to pull in that direction. Okay, and it's going to make an angle 15 degrees with respect to the vertical there. Why? Because if this is 15 degrees, then this is 15 degrees right here. Okay, that's the free body diagram. Let's set up the net force equals ma. Now, which way is the acceleration? We want to identify that by the context. Well, it's moving in a circle like this. The acceleration is towards, for the centripetal acceleration is towards the center of the circle, right? So that means I'm going to decompose my forces just like this. This is up and to the right, so I'll make it up and then a right, like make that right triangle. So that's t cosine 15 degrees is the adjacent side. T sine 15 degrees is the opposite side. And then now we're going to do F net equals ma for both the x and the y directions. So in the x, we have T sine 15 degrees. It's the only force pointing to the right or left, right? Because these are vertical. That equals m times v squared over r. Okay? That's our equation there. Y direction, we'll say up is positive. Oh, I made right positive in this case. That's why that's positive, and the v squared over r is positive. So up's positive, we'll say t cosine 15 degrees minus mg, because mg is downward. Downward's the negative direction vertically. So we'll look at vertical forces, vertical arrows. That equals m times 0, because there's no vertical acceleration. This thing is swinging like this. The acceleration is only towards the center of the circle. There's no up or down motion for this guy here. Okay, so those are equations. Now we want to solve for the speed. We want to solve for v. I got to get rid of the tension. I don't know what the tension is, right? So the t is going to be mg over cosine 15 degrees. And we're going to plug that right into there. So then we're going to get mg over cosine 15 degrees times sine 15 degrees equals mv squared over r. Almost the exact same equation as the banked ones, right? Very similar. And then the v is going to be the square root of rg multiplied by r. And then take the square root because we have v squared here. And so then, okay, so what is r? R, this is a little bit tricky. R is not the length of this rope. Don't be like, oh, the radius is 3 meters, because the radius of the circle is this. This is r right here, right? But you can see there's a right triangle here. There's a hypotenuse here that's 3. And so r is going to equal 3 sine 15 degrees, because this is the opposite side of the right triangle. You can do SOHCAHTOA if you want to. Opposite over hypotenuse is equals sine of 15 degrees. So r over 3 would be sine of 15 degrees. And so r is 3 sine 15 degrees. So then this is going to be 3 sine 15 degrees times 9.8 times sine 15 degrees. All I'm doing is replacing the r with the r here, divided by cosine 15 degrees. Okay, so that's going to be square root 3 times sine 15 times 9.8 times sine of 15 divided by cosine of 15. And I get 13.7 meters per second. Okay. What is the period of the motion of the ball? Remember that the speed is distance over time. This is the formula I remember, which is the circumference of the circle divided by the period. That means it goes around the circle once in a period, or t is equal to 2 pi r over v. Well, this is 2 pi times 3 sine 15 degrees divided by the velocity we just found. Okay, so 2 pi times 3 sine 15 divided by this number, and I get 0.35 seconds. Okay.